So now, we've been using acetic acid a lot of times. Let's try a different system. So this time we have formic acid as our weak acid component, and we have sodium formate as the source of the conjugate base. So just as a recall, so I will write the dissociation reaction of formic acid. So remember, it's a weak acid, so we use a double-headed arrow in writing the dissociation reaction. And the conjugate base is formate plus hydronium ion. And the Ka for this is 1.77 times 10 raised to negative 4. Now, the buffer is prepared by dissolving 0.400 mole of formic acid and 0.100 mole of sodium formate. Again, this salt, the sodium formate, will be the source of our conjugate base. So salts completely dissociate. Therefore, whatever the concentration of the salt is, that will be the concentration of our conjugate base. Again, this is a buffer, so we will be using the Henderson-Hasselbalch equation. But before that, we need to know the concentration of our components because the given is quantity. The given is mole, okay, the quantity. So to get the concentration, specifically the molarity, we need to divide the moles by the total volume of the solution. So for the molarity of formate, our conjugate base, we have 0.1 mole divided by the volume of solution is given 0.250 liter. So we don't need to add anything else. This 0.250 liter is the total volume of the solution. So this will be our expression for the concentration of the conjugate base. And then for the weak acid, formic acid, we have 0.400 mole divided by 0.250 liter. So the volume will be the same, again, because this is the total volume of the solution. So now we go to our Henderson-Hasselbalch equation. So pH is equal to pKa, and pKa is negative logarithm of 1.77 times 10 raised to negative 4 plus logarithm of, again, concentration of conjugate base. So we have 0.100 mole divided by 0.250 liter over the concentration of the weak acid. So we have 0.400 mole divided by 0.250 liter. Notice we can actually cancel the volume and we are left with the moles. So you can do this if you are given the total volume of the solution. Then computing for the pH of this buffer solution, you will get a value of 3.50.